Hey everyone, this is Aaron, and we're here with my daughter Malia. See, she's right there. We're actually doing some math problems here, and here's what we're doing. Okay, this is Mathematics Vision Project, Module 7 is what we're doing. We're doing congruence, constructions, and proof. We're going to be doing the first section in the book. So if you want to do that, you can just log on there, mathematicsvisionproject.org, and click on Module 7. You'll find, I'm not going to do it exact, but I'm just going to show you what you need to know in order to complete this. Now, I'm not a teacher for you guys. I'm just a dad. So if your teacher disagrees with the way I am teaching it, then do it your teacher's way. Don't do it my way. But I'm just helping Malia out. And since we're all stuck here at home, I thought some of you might want some help with this. And so did Malia. So here we are. Let us get started. The thing is with this, for doing constructions and proofs, we're going to focus first on constructions. And with constructions, you need a straight edge. When I say straight edge, you can use a ruler. You can use, like I'm going to use this edge of the triangle. I'll probably use this. Or you can use, this has a straight edge too, right? And then you'll also need a compass. So you'll need one of these. Okay, to do the constructions. So just, that's all. And now you cannot use the ruler as a measuring device. You can't use the straight edge as a measuring device. You just have to use the straight part, and then you're going to use this as the measuring device. Like if we say make a line segment that's congruent to this line segment, congruent meaning exactly the same, you can't measure it with a ruler. You're going to have to use the compass and the straight edge, or this straight edge, or you can use the side of a credit card, or the side of, I don't know, side of your book. That's kind of hard to use, but anything that's straight. So here we go. Let's get started. Okay. Let's say that you have, see how I use my straight edge there to make a line. Let's say you have a line segment AB. Doesn't matter how long it is. And you are asked to make a line segment that is exactly the same length as that without using a ruler, right? You can only use your compass and your straight edge. All right, so here's what you do. So go ahead and you can draw your own line like that. Just doesn't matter how long it is. But you want to make one that is congruent, which is exactly the same length. And all you have to do is just go like this. I don't care where you draw, just draw it anywhere. Just draw a line. Make sure it's longer than the one that you have. And let's call this A prime, okay? And then you just take your compass, okay, see my compass here? And you make the compass the same length. Make sure you got a good, nice, strong compass that doesn't get loose. It has to be a nice, tight compass that keeps its shape. And you measure it like this. I go from A to B. See that? Point to point. Now compasses just make little circles, right? So you want to put the sharp end right here, I call it the dangerous end, on the A, and you just strike a little arc. Instead of a circle, you just do part of a circle. Strike an arc right there, boop. And where it intersects, that's where you put your B prime. And now this line segment is exactly the same length as that line segment. Okay, next what we're going to do is we're going to construct a perpendicular bisector. Okay, so just go ahead and draw a line with your straight edge, like this. Let's call it line segment CN in honor of Chuck Norris. So what we're going to do is we're going to create a perpendicular bisector. That means this line is going to be both perpendicular, so it's going to form a 90-degree angle, and at the same time it's going to cut this exactly in half. Now, a couple things. You can't use a protractor to make it 90 degrees. You can't measure it with a ruler. So here's what you do. You take your compass and you make it go past the halfway point. Okay? And what you're going to do is you're going to strike an arc above. See, I have it on the C. I pick up my sharp part on the C. I strike an arc above the line segment, and I strike an arc below the line segment. Okay? Then you keep it exactly the same. It cannot move. It has to stay stationary. Do not change the length of the compass. It has to go past the halfway point, and you strike above the line segment, and then you strike below the line segment. Now, you take your, I barely can, see where they connect? Where the intersecting points are, you take your straight edge, you line it up, you draw a line, and you connect them. That just happened! What just happened? Well, we just made it, look, this is perfectly 90 degrees and it cut it in half. Right? There you go. Now you go ahead and try that yourself. Make it yourself. You got to do this yourself. Don't just watch the video. You have to try this yourself. Get out your straight edge and your compass. Okay. All right. Next, what I'd like you to do is just make an angle, make any angle. Okay? I'm going to make an angle, make any angle. So I try to get it so you can see it. Any size angle. By the way, the term, I don't know if I explained to you, but the term bisector, to bisect something, means to cut it in half. Okay, so what we're going to do, see there's my nice little angle. We'll call it angle A, B, C. We can label this as angle A, B, C, going this way. What else can we name that angle, by the way? What is another name for that angle? There's another name for it.
CBA.
Angle, yes, CBA, right? Very good. So, what we're going to do is we are going to bisect this angle, or draw a ray so it cuts it exactly in half. Okay, so first what you're going to do is you're going to strike an arc from the vertex B. So you put the dangerous end, the sharp end, on B, and you strike an arc like that. Okay? Now that's going to give us like a reference point. Now what you do is you keep your compass locked, and see this intersecting point that you made from here. You're just going to put the sharp end right there on the intersection of that new arc and the ray, and you go ahead and you strike an arc above, and then you put it on this intersection, and of course you're going to strike an arc below. I think that wasn't a very good arc there. That is not a good arc. I'm going to erase that arc. Always do it in pencil in case you make a mistake. Okay, let's start over here. So you strike an arc above. Let's erase that whole thing. I think my compass, if your compass changes, if it gets loose, then it won't work. So let's see. Make sure your compass is locked tight. So I'm going to strike an arc above. Strike an arc below. Now guess what? You take the intersecting points from the vertex and those intersecting points and you just connect them. And now you have this angle that is congruent to that angle. Okay, next on the world of constructions, what we need to do is to learn how to make congruent angles. So, here's how you make congruent angles. You have an angle, let's just make any random angle. Make any random angle like that, okay? Now I want to make one, I just made it, right? I just made an angle. Call it X, Y, Z. So to make it the same, make one exactly the same, first you just have to get a, right, easy. This is the easy part. Just take a line right here. There's our, make little arrows there, just because I like the arrows. X prime, Y prime. Okay, that's the easy part. But we want it so it's the same width, because angles are kind of like width like that, width like that. So what we do is, guess what? Just take your compass. Now you're going to take it, you're going to lock it, and strike an arc like that. And you're going to take this, you're going to lock it, and you're going to strike an arc. Okay, so it's the same length, sorry. Look at our compass, same length from the vertex of Y. Then you do the same compass length from the vertex of Y prime. You're going to strike an arc like that. Okay? Now these are the same distance apart. So all we need to do now is figure out, hey, how wide is this compass at that distance? How wide is this angle at that distance? So you take your compass and you measure it. Okay. From that arc, this compass is that big like that. Right? So then you just take it like that and we measure it. That's the same length. See, same length. And you just strike an arc. And guess what? At that point of intersection and this angle, see where they intersect? And the Y prime and that angle, that point of intersection of the arcs, line up your compass, your straight edge. Boom. Right there. And then there, that's Z prime. And now we have two congruent angles. Okay, now you go ahead and try that. Now remember, when we're making angles that are congruent, we don't care how long the rays are, because they go on forever typically. Like I should have a little arrow right here. What we're trying to figure out is, how do you measure an angle? When you take a protractor, you measure how open it is, right? So the openness is the same. Don't worry about the length. We're not worried about the length of the rays. We're worried about the actual measurement of the angle. Now, there's a couple things. Let's go to that was the ready, set. Let's do the go. A couple problems I want you guys to solve. This is 9, x equals 11 plus y, and then 2x equals 2x plus y equals 19. What we're going to do is we're going to solve for the system of equations. Okay? So solve for the system of equations. Okay. So the way to solve this is we can see that x equal to 11 plus y. We see the x is by itself. By the way, solving for the system of equations is finding the point of intersection. This is because as an x and y, it's going to be a line. And this has an x and a y, it's also going to be a line. So I can take this 11 plus y, and since it's exactly the same as x, I can plug it into that x right there. Sorry, plug it into that x right there. So I can write this equation as 2 times 2 times something plus y equals 19. Instead of x, we could put in 11 plus y. And we can go ahead and multiply it out. 2 times 11 is 22. 2 times y is 2y plus y equals 19. 2y plus y is 3y. 22 plus 3y equals 19. Take away 22 on both sides. 3y equals 19 minus 22 is negative 3. Divide by 3, and y equals negative 1. We are not done because we also solve for x. So let's plug the y into there and say x equals 11 plus negative 1. 11 plus negative 1 is 10. Now our system of now you can also plug the y into this equation to check your work. 2x minus 1 equals 19. Add 1, 2x equals 20. Divide by 2, x equals 10. So they both work, so I know my answer is correct, but you must write your answer as a point of intersection 10, negative 1. And that will be your answer. Okay, let's try this problem here. Solve the system of equations. This is number 12. Y equals negative x plus 1. And then y equals 2x plus 1. We can set them equal to each other and say 2x plus 1 equals negative x plus 1, because basically they're both equal to y. So if this is equal to y, I have a y right there. I'm basically just plugging that in there, or vice versa. Then you add x. Let's get everything on one side. Add x. Add x. We could take away 1, take away 1. This becomes, add x. This becomes 3x equals 0. Divide by 3, and x equals 0. Plug the 0 into the equation. Y equals negative instead of x. We do 0. 0 minus 1 is y equals 1. 0, comma 1. Okay. Make sure you write your answer in that form right there. And then one last one that I want you to try, and then the lesson will be done. Let's do, that was substitution. Let's try an elimination method here, number 14. So let's say 4x minus y equals 7. And this is negative 6x plus 2y equals 8. Now, the elimination method, you can see that since the numbers line up with the number, the equals line up with the equals, the y's line up with the y, and the x's line up with the x, we can eliminate. But what we want to do is figure out what we want to eliminate. Do we want to eliminate x, or do we want to eliminate y? Which one should we eliminate? Well, I can see that the y is kind of the opposite, but it's not the same. So we can make it the same. So I can multiply this whole thing by 2. Multiply everything by 2. Left and right. 2 times 4x is 8x. 2 times negative y is negative 2y, and 2 times 7 is 14. Now, see, they're the opposite, but the same. Sorry, my hand's in the way. Sorry about all that. They're the opposite, but the same. Multiply all those. I can go ahead now, and what I want to do is I want to add them. Negative 6x plus 8x is 2x. 2y minus 2y is 0. And 8 plus 14 is 22. Divide by 2. I get x equals 11. Okay, now I just take the 11 and plug it into any one of these. Any one. Now let's do it with our original one. 4 times 11 minus y equals 7. 4 times 11 is 44 minus y equals 7. And we take away 44. 7 minus 44 is negative 37 equals negative y. Now this is negative y, so I could divide by negative 1 or multiply by negative 1 and get y equals positive 37. So our point of intersection, and then, you know, plug this in another equation to check your work, but Malia did the same as me. We get the point of intersection is 11, comma, 37. And there's your first math lesson.
Wiggles.
Couple things. I don't know if your teacher will want you to do constructions. I don't know if those are on the if you're going to be tested on the SBAC with those. So I don't know. Do with this with what you need. I don't know if you're going to be doing constructions or not, but they are there for you. All right. This is Aaron and Malia signing off. Good luck to you guys.
Bye.